Okay, good afternoon, grade 9s. I'm just waiting till the time, till 3:15, for everybody to get ready and organized, and then we will start with our next lesson on algebra and grade 9 mathematics. We've made some good progress so far with knowledge of exponentials, and now we're going to start looking at expressions, how to simplify expressions, taking everything that we've learned already a little bit further. So we'll just wait a little bit longer for other people to join us for this session. I'm going to put up a page that you could copy down if you want to, little bits of it, and then we will add color and make sense of it after that. Okay, hello everybody. If you're getting ready to tune into today's lesson, you can just get a fresh page to start writing things down. Get your pens and pencils ready. If you've got some colors, sometimes that helps to highlight things, do things in different colors. Just looking forward to chatting to you again today about maths, and hope that you are feeling confident, that you're learning something, and that you're going to be doing so much better, I hope. There are lots of little tricks and small things that we have to learn and remember, and it takes quite a lot of effort, but if we keep at it, we will get there. I'm just waiting till 3:15 to start the session. Okay, hello everybody. Welcome to the next lesson of maths. We're going to be taking our algebra knowledge a little bit further. This is lesson 4, and some of it will be needing to learn a bit more terminology. Some of the words we've come across already, so that should be helpful. And we're going to start simplifying expressions in algebra, being able to multiply into brackets, being able to know how to add, how to subtract. We've already learned a lot about multiplying with exponents. So now we've got to put all sorts of things together that we've already learned. Okay, so let's get going today. I'm going to start lesson 4 by looking at some algebra terminology that we need to know. And some of this we've already discussed previously, but let's have a look at it again. Okay. So far, if I present you on the screen with an expression like this, this we would call an algebraic expression. And can you see that it's written with the term with the highest exponent first, then the next highest exponent, then the next one, and then the last value, which is just a number. Okay. Now we've come across some of this language before. The term coefficient means the number that stands in front of the algebraic part of a term. Oh, but what is a term? Okay. A term is, in an algebraic expression, as soon as you see a plus between two things, that identifies a change from one term to another, or a minus. Okay, so let's separate the terms. If we separate the terms, then there's one term, 5x to the 4. There's the next term, 3x squared. Then our next term is minus 12x, because I'm actually taking the sign with the term. And then our final term is minus 8. Okay. So in amongst that, we need to be able to use all the words of maths. And so last time, when we've been working with exponents, we said that these numbers that stand in front of our x or y or whatever variable we're using are called the coefficients. So over here, the minus 5 is the coefficient of the x to the 4 term. The 3, we can say plus 3 or we can say just 3, is the coefficient of the x squared term. The minus 12 is the coefficient of the x term. And then that 8 is standing all on its own. It's not a coefficient. Alright? It doesn't have an algebraic part. So we call that the constant term. So why is it a constant term? Well, because no matter what we let x be, it will always be minus 8. There's no x there to change its value. We know that if we sub in a value for x, that whole term will have a full numerical value. Like say we let x be 1. Then x to the power 4 would be 1 times 1 times 1 times 1. And this whole term would become minus 5 times all those 1s. The whole term's value would be minus 5. But if we let x be 2, then we would have 2 times 2 times 2 times 2 there, which, let's think about that one while we're about it. If I had 2 times 2 times 2 times 2, I'm going to make it easier for myself to say those 2, which multiplied together would give me 4. These 2 multiplied together would give me 4. And so my final answer would be 4 times 4, which is 16. So then this term, it wouldn't have a value of minus 5 anymore. It would be minus 5 times 16. Alright. But what I'm getting at is that this term, no matter what we let x be, it just stays the same. Okay, so that's why we call it the constant term. Constant meaning that it doesn't change. Right. Then we've been working quite a lot with index, the word index or exponent. Mostly we use the word exponent. So I'm going to highlight the 4 and the 2. These they are each called an index or an exponent. If we want to use the plural of index, it is written as indices. Indices. Oh gosh, I'm not sure how to spell that. Let's not bother. Okay. All right. So, we'll take that off. We'll just say an index or an exponent. And then, what do I mean by the word variable? Well, the variable is the part of the expression that can change. And that's what we were talking about earlier, that x is our variable. We can let it be 1. We might let it be 2. We might let it be minus 3. So the x is the thing that can change. and depending on the value of x, this whole expression will have a different value. So the variable in this case is the x. The variable is the x. Okay, so we've got some language to do our algebra with. And we've kind of done that stuff before, so I hope that you have managed to write that down and put in the few terms that we need to know. All right. Notice again that we generally in maths, we prefer to write our expressions with the highest exponent of x first, the next highest, and the next highest down to the lowest. Okay? And so because of that, we're interested in what is the power of the first term, of the highest term. What is that power? And we give that a very special name. So the highest power of the variable, we give the word degree to. Okay, so this expression that we've just put up there has degree what? We just say it has degree 4. It is a 4th degree expression. Okay? So that's another word we need to know, the word degree. If you're managing to keep up and write things down, so the word degree, we just write down the number that is the highest power of the variable. If we ask for what is the degree of the expression. And then there are a few more words that we need, and they're all quite similar. And if I look at this expression, you see, we talked about how many terms does it have. Well, that's my first term, second term, third term, fourth term. So this is an expression with 4 terms. And terms are so important to us in maths, especially in algebra, you'll come to see why in a while, that we actually name our expressions according to how many terms they have. Okay? And the words that we use are English words, and a lot of them are based on Latin or French derivatives. But if you have a look here, we will call an expression that has only one term, we call that a monomial. So mono is a root word that kind of means one. Mono. So a monomial has only one term. A binomial has 2 terms. If you think about the word bicycle, that comes from having 2 wheels. Or the word binary also means 2. What else do we use when we have bi? Can't think. Okay. But a binomial is an algebra expression with 2 terms, like that. And then, of course, we get a trinomial. And you know, the word tricycle is a bicycle that has 3 wheels. A three-wheeler cycle is called a tricycle. So a trinomial has 3 terms, like that. You see there's an x squared term, an x term, and a constant term. And finally, once we get more than 3, we just call it a polynomial, because poly means many. Okay, so we need to know the word monomial, binomial, trinomial, and polynomial. They're not... You're never going to be asked what kind of an expression this is. Oh, it's a binomial. But actually, it's just part of the language we're going to use to talk about maths. So it helps. But especially, we're going to talk about a binomial. How do we multiply, for example, a binomial times a binomial? How do we multiply a trinomial by something else? So we are going to refer to these expressions with these words. Okay. So you'll just hear them coming up in the way we talk in maths. And so it's important that you know what those terms mean. All right. So I'm going to try and summarize and say again what these important terms are. All right, I'm going to go to my next screen and give you another version of what's really important to know about in terms of language. Okay, let's go. Okay, so for algebraic expressions, we must know the following vocab of maths. We need to know the term. What is a term? What is a term? And we discussed it just now. We say terms are separated by plus or minus signs. Okay. Right, that's a term. What is a coefficient? A coefficient is the number in front of the term with its sign. So it's the numerical part of the term, the non-algebra part, not the a or the b or the x or the y squared, just the numerical part. And it's important that it has its sign. Its sign goes with it when we talk about the coefficient. Okay, what about the variable? Well, it depends what letter we use to put in our expression. We can have a variable that has x in it. We can have a variable that is a p. We can have a variable that's a y. We can have a variable that's a z. It all just depends what unknown, what symbol, what letter we've used to represent our changing value. So the variable, vary, in English means change. Variable, it's the changing thing. Okay? And then, very importantly in this session, we're going to talk about like terms. Now, what do we mean by like terms? Like terms are where we have terms which have the same variables with exactly the same powers. Let's just put that as a with. Exactly the same exponents. Exactly the same exponents. I.e., only the coefficients differ. So, I'll give you some examples of like terms just now. So, a like terms are two or more terms that have the same variables with exactly the same exponents. So, every bit of them, algebraically, is the same. All the algebra bit, all the x, all the y, all the squares, all the powers, the exponents on the algebra is exactly the same. And the only thing that differs is the coefficient. Those are like terms. Right. And then finally, the last thing that we mentioned already is our degree of an expression. And we said the degree is the highest value of the exponent on the variable. Okay, so maybe that's starting to make sense to you. You're able to use that language. A term, a coefficient, a variable, like terms, and degree. Right. So with that said, here are some examples of like terms. Alright? So in my first example there, I've got a 2x squared minus a 4x squared. Alright? They are both x squared terms. Their algebra part is x squared. Nothing different. Exactly the same in both of them. But because they're like terms, we can actually add them or subtract them. Okay, so what are we saying there? It's like I've got a thing in front of me called an x squared. It could be, so you say, I've got two of these things. Okay, because when you put a 2 in front, it means 2 times that thing. And times sometimes can be understood to mean of. Right, so I've got 2 of these x squares. Then I want to subtract 4 of them. Okay? So I had 2. Now I want to subtract 4. Well, that's interesting because in positive numbers we couldn't have subtracted 4 from 2. But if you think about your number line, you say, I'm here at 2. I'm going to subtract 4. So I'm going to go minus 1, minus 2, minus 3, minus 4. I've got to subtract 4 of those things. And if we're on our number line and we're moving to the left, the next value here would be a 1. That would be our 0. That would be our minus 1. And that would be our minus 2. So actually 2 minus 4 gets us to minus 2. So I had 2 of these things. I'm subtracting 4 of them. My answer is that I've got minus 2 of the same thing. Right, if you're adding things and or subtracting things, you can only have more of them or less of them. The items that you're adding and subtracting are still the same. They're only x squares. Let's try again with the second example. Okay, so look, the algebraic part there is x, y, z. The algebraic part there is x, y, z. So that means they are like terms. And if they are like terms, and only if they are like terms, we're allowed to add them. So it's like a certain kind of a thing. I've got 7 of something called x, y, z. And then I'm adding on 12 of those same things. 12 more x, y, z. So what would you do? Now, this is an easier one to do because I know how to add 7 plus 12. So 7 of something plus 12 of something. Okay, 12 plus 7 gives me an answer of 12 plus 7, 19. And what have I got 19? I've got 19 x, y, z's. The same thing. I can't change the nature of the thing that I'm adding up. I'm just adding. I've got the same things, and then some more of them, and I add them up. X, y, z. Okay, so that is what we mean by like terms. Alright. So I'd like to, at this stage, let you start working on an exercise. Again, I'm working from Platinum Maths, and I'm going to put the exercise up on the screen, and for you to try, and we'll do some of the exercises. Okay. So this is exercise 8.1 from Platinum Maths, and I would like you to have a look at them. Work from the screen or work from your textbook if you have a textbook. And you can see that some of these questions are fairly straightforward. You can answer them quite quickly, and I'm going to give you some time to try and do that. Okay. Alright, so I suggest that you start doing this exercise, go as far as you can, in a little bit of time, give us a few minutes, and then we'll start talking about it together and going over the answers. Okay. Okay, I'll just give you just a little, one more minute, and then we'll start going over the answers. Alright, and some of the questions can be answered very easily, And others, you need a bit of space to actually work out the answers. But I'll show you how we should do that. Okay, let's start, because we want to use our time that we've got to the best advantage. Alright, so the ones that are easy to write the answers, I'm going to write them next to the questions, and otherwise we'll have to find some extra space. Alright, so write down whether these expressions are monomials, binomials, or trinomials. Alright, what did we say those terms meant? The monomial just means it's got one term. The binomial means it's got two terms, and the trinomial means it's got three terms. Okay, so this one, see this is an x squared term, and this is a y term. It's 2x squared and 11y's. Those are definitely different terms. We couldn't add them if we even tried, because they are unlike terms. And there are two of them, so we'll say this is a binomial. Binomial. Okay, let's look at the next one. My first term is an ABC term. My next term is a BDP term. You see, separated by a minus sign. And my next term is an FGH term. They're all totally different kinds of terms, algebraically. And so if we ask the question, are they like terms or not? They are definitely unlike terms. See, the algebra in each one is totally different. But they are separated, your term, the terms are separated by plus and minus signs. And so here we have three terms. So we'll call that a trinomial. Okay, right here, trinomial. Right, next one. I've got an AB term and an AB squared term. Now, those two are totally different as well. Remember we said for them to be like terms, that have to have exactly the same algebra. Now they both have AB, but the one is B squared. So that's a different term altogether. So here again, we've got two terms, binomial. And here, last one, well that is a bracket cube. Now we've talked about exponent work there. We've done exponents like that. If we've got a bracket and a cube outside, can you remember what that meant we had to do? Well, it meant it's going to be 27m squared n times 27m squared n times 27m squared n. And we actually learned that that means that the 27 would be raised to the 3. The m, we learned a quick trick that said if you're raising something that's already a power to another power, you can multiply the exponents. I hope you can remember that. So now this is going to be m to the 2 times 3, which is 6. And this is going to be n to the, there's a hidden little number 1 in there with the n inside there. So it's going to be n to the 1 times 3. Oops, sorry. N to the, I'm messing up my board here. I apologize. N to the 3. Can you see that even when we expand it, even when we give it a better answer, it's just one term, right? There's no pluses or minuses, so this is a monomial. Okay, monomial. Right. Let's go on to the next question. Now, the next question talks about finding the value of this expression. You see the expression's got x's in it. And so the x is the variable. The x can take on a different value. And the first value they want us to give it is 0. Okay, so I'm putting this under my camera to show you. camera. Okay. So here we have the expression, and the first thing they want us to do is to let the x be naught. What will the value of the expression be if x is naught? Well, what we do is we take that expression, everywhere we see an x, we put the naught. So we go 4 times naught, and it helps to put it in a bracket to show that I'm going to square it. Plus 10 times naught minus 17. So, can you see that naught squared is still naught? Naught times naught is still naught, and if I times the naught by a 4, I still get naught. So that term is just naught. We can write that if we like. This term is 10 times naught, which is also naught. And then this term is our constant term. It just stays what it was. And so the answer for this expression when x is naught is 17. Oh, sorry, negative 17. Yeah, because that was minus 17. Okay. Let's take the same expression now and substitute 6. Okay. So here's our original expression. We're going to take that same original expression and put the 6 in. So I write 4 and then 6 squared. Plus 10 times 6 minus 17. Okay. Now we've got to know what 6 squared is, and 6 squared is 6 times 6, which is 36. Oh, now we've got to do 36 times 4. Does anyone know how to do that without a calculator? Okay. I do it like this. 4 times 6 is 24. Carry 2. 3 times 4 is 12. And those extra 2 makes 14. So this term alone becomes 144. This term, if x is 6, becomes 6 times 10, which is 60, and then minus 17. And maybe at this stage, we can be allowed to pick up our calculator and work out what that comes to. So 144 plus 60 minus 17. Who can get there fast? I think I'll just use my calculator. And you're allowed to, obviously. 144 plus 60 minus 17. I get 187. Okay. And then the last number they wanted us to do was negative 4. Now notice it's important, the negative is very important. It's going to change things a bit. So let's be very careful how we write it down. So here's my original expression. So I'm going to go 4 times negative 4 squared plus 10 times negative 4 minus 17. Okay, let's see what happens here. When I square minus 4, that is minus 4 times minus 4. And we've said in some of my other lessons that if we've got a minus times a minus, that has to make a plus. So that's 4 times 4. So that just that bit is positive 16. That bit is positive 16. And I've got to multiply it by 4. And I happen to know that that gives me the number 64. Okay. Then 10 times minus 4. A plus times a minus is a minus 40. And our minus 17 tacked onto the end. This I think I can maybe do without a calculator. 64 minus 40 was going to give me 24 minus 17. And how far is it from 17 up to 24? Well, it takes 3 units to get to 20, and then another 4. So I think my answer is going to be 7. Okay, so the first question's answer was negative 17. Next one, 187. Next one, 7. So you can see what we mean by a variable. That x can have all sorts of values. And depending on its value, the expression has different values. Okay. Let's go back to the questions that were in the textbook, now that we've done that one. Okay, now we're on to number 3. What do we see in number 3? It says, in this expression, how many terms are there in the expression? Well, we've got 12x squared, that's our first term, plus 2x, that's our second term, and minus 15, that's our third term. So our answer to that is, write down the coefficient of x squared. So where's the x squared term? Oh, here it is. And I often use this sort of pinky color to represent the coefficient. Alright? So the coefficient of x squared is 12. What is the value of the constant term? Okay, what's the constant term? The constant term is the bit at the back that has no x's. Well, it doesn't have to be at the back. It's just the part of the expression that has no x's in it. In other words, it never changes its value, so it remains constant. And remember that we said the sign always goes with the term. So we call the value of the constant term here, the answer is negative 15. Not just the 15, but the negative as well. Alright? Then calculate the value of the expression when x equals negative 1. Okay, so I need more space to do that. So I'm going to flip to my camera to do that. If everybody's ready to do that. Okay, so this is number 3. That was the question. And we had to work out what is it? What is the expression worth? What is it equal to when x is negative 1? Let's take it very carefully. We put down the 12. Then we put minus 1 in brackets squared. Then we put plus 2 and minus 1 and minus 15. Now, remember that if we take a minus 1 times a minus 1, the minus times the minus will give me a plus. So, and 1 times 1 is just 1. So this is just 12 times 1. Stays 12. Then, I've got plus 2 times minus 1, and a plus times a minus is a minus 2, and then the minus 15, which was our constant term, and it doesn't change. Sometimes it's easy to do this sort of stuff in your head if you, let's gather up all the minuses. So I've got positive 12, that's the positive part. And now I've got minus 2, subtract another 15. So if you're working in your head with a number line, here is my 1, here's my 0, my minus 2, etc., minus 3, minus 4, etc. Okay. I'm wanting to work out what these two terms come to. I'm starting already at minus 2. And now I have to subtract 15. I'm subtracting a normal old number. We know that when we subtract a normal number, a 15, I'm going to minus 15, I've got to go in this direction. So where are we going to land up? Well, I'm already at minus 2. So if I hop this way another 15, I'm going to be at minus 17. And so now it's maybe easier to see. Okay, I've got minus 17 and a plus 12. So again, what is this question saying? I'm starting way here at number 12, then 11, then 10, etc., 9. So I'm starting here at 12. Now I'm going to subtract 17. So if I hop like this 17 times, well, by the time I get to 0, I will have hopped 12 times. Okay, when I get to 0, I will have done 12 hops. So how many more do I have to do into the negatives? It's going to be 1, 2, 3, 4, 5. I'm going to land up at negative 5. I'm not sure if that helps. You are allowed to use calculators, but it is helpful to be able to do things for yourself by thinking. I really encourage thinking about the number line. Okay, let's go back to our questions. Write on the degree of the expression. We've sorted that out. The degree of the expression is the highest power of x. What's the highest power of x? I see it there. It is 2. 2. Then, next question. Are these, we're into number 4 now, and maybe you didn't get that far, but let's try and do it together. Are these terms like terms? What are we asking? We're saying, do they have exactly the same algebra parts? I'm not worried about the coefficients, the numbers, the coefficients in front. I'm worried about the algebra. Well, they do have x's and y's, both of them, x's and y's. But the first term's got x squared, y cubed, and the second one has got x cubed, y squared. So it's all mixed up. It's changed. Can you see it's changed? So the answer is no, they are not like terms. What about the next one? Okay. These next one, they've got A's and B's. A's and B's. You see the second one, they put the A's at the back and the B's at the front. But that doesn't matter. In fact, we prefer in maths to write our algebra in alphabetical order. So let's just rewrite this term here in alphabetical order. I keep my -2. I'm going to put my a squared first and my b cubed second. Okay, we prefer that. It's a convention. It just means it's a way we like to work in maths. So now, when I rearrange that into the alphabetical order that we like, can we answer the question, are these like terms? Well, yes, they've both got A's and B's, and the A is squared in both, and the B is cubed in both, so yes, they are like terms. Okay, yes? Whoops. Answer here? Yes. Alright, and now we're getting into adding and subtracting. And I hope that you've learnt already in your maths that you can only add and subtract like terms. Because if I've got 10 apples plus 4 apples, I've got 14 apples. So if I add things, if I add items, like if I add books, I've got 3 books plus 4 books, I've got 7 books. If I have 3 books and somebody comes and takes 2 of them away, then I've got only 1 book. So you can only add and subtract things that are the same. I can't say I've got 2 apples and 2 books, so then what have I got, 2 apple books? No, I don't. Okay? So that's why we have this ruling that says you can only add and subtract like terms. In other words, you can only add and subtract things that are the same kind of thing. Alright, so let's look at our first question. Now this is saying I've got 7 x squareds and I'm subtracting 14 of them. Okay, it's quite hard to conceptualize subtracting more of something than we have. But that's a concept that we manage once we get to high school, where we say, okay, if I have 7 minus 14, let's go to my other page here, and just get this really, really clear. Okay. If I have 7 minus 14, what does that mean? Well, it's the same story as I was trying to indicate to you just now with the number line. Okay. So, our number line is such a useful concept. So if I've gone 1, 2, 3, 4, 5, 6, 7, there's my 7. And then minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Okay? And so I'm trying to do the sum, 7 minus 14. Well, if I'm sitting at 7, and I want to subtract 14, it's going to take me 1, 2, 3, 4, 5, 6, 7 hops just to get to 0. And then if I do another 7 hops, I can see that I'm going to land up at minus 7. Because I had to subtract 14. 7 of them took me to naught, and then another 7 of them took me to minus 7. Okay. And so now if we add the x squared, we say I've got 7 of this kind of a thing, subtract 14 of the same kind of a thing, I'm going to have negative 7 of that kind of thing. It's like saying 7 apples minus 14 apples. Although we can't quite conceptualize minus 14 apples, it's like you owe me 14 apples. Or you, I have 7, but I'm supposed to give 14 away. Well, I can't. I'll be in debt by 7 of them. So that's why it becomes minus 7. All right. So let's go back to the questions again. So my answer here is that I say, oh, you see the question said if possible. Simplify if possible. What do they mean by that? Well, they're bringing to your attention that you can't always add and subtract. Again, you can only add and subtract like terms. So could we add and subtract x? This is an x squared. This is an x squared. This is an x squared. So yes, we can subtract them. And as we just said, I've got 7 of them minus 14 of them. Sorry. I've got negative 7 x squared. Let's go to B. Okay. Have we got like terms here? Right, my first one is an ABC term. Next one says BCA, but does that matter? Is BCA the same as ABC? Yes, it is. Okay, last one says ACB. But if we just rearrange them into alphabetical order, it'll also be ABC. Okay, so in algebra, like we said, our convention is we would write our letters in alphabetical order. So actually, all 3 of those terms should be ABC terms. Let's write them again on a piece of paper and see what happens. So the question, we can change it so that it's all alphabetical order. So we've got 15 ABCs. Then we've got plus 12 ABCs by just putting them in the right order, minus 13 ABCs. So we're adding and subtracting things that are the same. Okay, so all I have to actually add is the 15 and the 12. What is 15 and 12? Well, the 10 and the 10 will make me 20, and the 5 and the 2 will make me 7. So I've got 27 ABCs, and now I have to subtract 13 of the same kind of thing. If I subtract the 10, I'm going to have 1 there, and the 7 minus 3 gives me a 4. So my answer is 14 ABC. Okay? Next question. Right, let's look again. Are these like terms? Can we add and subtract them? Well, this one is an xy squared. This one is an x squared y. They seem similar, but they're not identical, are they? They're not the same. So we have to say, well, I can't add those. It's like saying, add 3 puppies or 2 dogs. Well, what am I going to get? Some sort of combination of the 2? No, I've still got 3 puppies and 2 dogs. So here I've still got 8 xy squareds and 7 x squared y's, and I cannot simplify it further. Okay, so we just said, you can write something like cannot simplify. You cannot simplify that one. Because they are unlike terms. And the last one, are they like terms? Yes, I've got 100 x squared y cubed minus 50 x squared y cubed. I've got 100 of something minus 50 of the same thing. I'm going to have 50 of those left over. 50 x squared y cubed. All right. Okay. Guys, I think that we should move on a little bit. If you have access to this textbook, or you have access to, or you can take a picture of this exercise, you can try and do the rest of them yourself. But I want to go on and teach a little bit more as well. Okay? So, let's just talk this one through. If you had to add those polynomials, notice you would only be able to add the x squareds to the x squareds, and the x's to the x's, and the 3 to the minus 4. Alright. Okay, so x squareds, look, we'd have one of them, plus another one of them, we would have 3 x squareds. Then we'd have minus 4x, and then add 4x. Oh, minus 4x plus 4x. If I have minus something and then plus something, where do I land up? I land up with nothing. So that will be nothing. There will be no x's left over. And then this would be 3 minus 4, which would be minus 1. So the answer to that one, just as an example, before I move on to something else, the 2x squared plus the x squared gives me 3x squared. Okay? Then minus 4x plus 4x. Well, if you say minus 3 plus 3, can you see? You just back at naught. Minus 4 of something, plus 4 of something, back at naught. So we don't even write that one down. And then the last one is plus 3 minus 4. And I know that if I add positive 3 and I subtract 4, I just get minus 1. So what I've written here is the answer for 6a. But I'm going to carry on now and do a little bit more teaching. Okay, because we want to use our time to the best, the most we can. Alright. So, the next thing I want to focus on is what do we do when we have a bracket? Okay. What is meant when I put something next to a bracket? Well, we've already actually used brackets today. Remember when we had to find the value of the expression when something was 1 or 0? We understand that when a 4 sits next to an x squared, that actually means times. So this means times. And so when I wrote that, the 4 next to a bracket, that also means times. Okay, so if we have one expression, an expression right outside a bracket with another expression inside, we know it means times. Okay. So now we're going to work on multiplying out with brackets. Okay, so a value or algebraic expression written directly next to a bracket implies multiplication of the two. Alright? So, what have I written here? Monomial times binomial, meaning we're having something with just one term multiplied by something with 2 terms. And as we've understood with brackets before, if something is in a bracket, it means everything in the bracket is going to be affected by what's outside the bracket. Okay. So this little sum here, if it says simplify. Now the word simplify is it's not very clear, is it? But we have to understand what is meant there is that we must do what the bracket's telling us to do. So what is the bracket telling us to do? It's telling us to multiply. Because when you put something next to something else with a bracket, it means multiply. And it means that everything in here must be multiplied by the 7a. Okay. And because we've been working with exponents, we might feel quite confident about doing this multiplication. Alright, let's try. So, if I want to multiply 7a times a squared minus 3b, it means the 7a must be multiplied by that bit, and the 7a must be multiplied by that term. Okay, so both the terms must be multiplied by 7a. And so, if you're not sure what to do, you can think on the side. We've got 7a times a squared. And because we've been working with exponents, we know that that means I'm going to put down the 7, and then the A's have got a base with some powers, and the power on the first one is actually a 1, and the power on the second one is a 2. So I put down my base, and I add my powers, a cubed. So my first answer here is 7a cubed. Alright. Now I've got to do 7a times, and notice we've talked a lot here about how the sign, the minus in the front, sticks with that term. So actually what we're having to say here is 7a times minus 3b. Okay, what would we get? We get a plus, because that's what's implied by the 7. A positive times a negative has to be a negative. A 7 times a 3 has to be a 21. And then an a times a b, well, the best we can do there is just say a next to b, which means a times b. Okay, so my answer here is negative 21ab. Okay, so if you need to write the little sums at the side, do that. If it helps and it makes things clear for you, then do that. Okay. Just taking away my extra little dots. Okay, what about the next one? Shall I give everybody a moment to write things down? I think I'll just hesitate for a few seconds, half a minute, so that people can write down what they might want to write down. Okay, let's do the next question. Well, this is a bit of an odd question as well. Look, there's a minus x at the front next to the bracket, and then there's a y at the back also next to the bracket. So what does that mean? It means this must be multiplied by this, which is multiplied by this. Okay. Now, also, in one of my other lessons, I've said to you, if I have, for example, this is just a little side example, if I have 2 times 3 times 5. Let's see what that gives us. So I can say that 2 times the 3 is 6, and the 6 times the 5 would give me 30. Oh, my pen is not writing well. Let's try again. 6 times 5 equals 30. Okay, we've got the answer. Alright, but what if I change the order? What if I said instead 2 times 5 times 3? That's quite a nice order, because 2 times 5 is actually 10. And I know that's very easy to do. 10 times 3 is easy to do. That's also 30. Okay. So what that shows you is that when you're multiplying a set of things together, it doesn't matter if you change the order. Right. So I think I'm going to move that y to be next to the x. So, let's see, this is saying, it's saying minus x times the bracket times the y. So is it any different if I say minus x and then times, we just put algebra next to each other, just means times, see, minus x times the y, and then times the bracket. And because of what I showed you just now with the numbers, we know that that is just the same. Okay, so the minus x times the y in front times the bracket. And we can't, the minus x times the y, we can't do any better than that. It's just minus xy. That's the best we can do anyway. Right? But now, the bracket says I must multiply everything inside the bracket by the minus xy. Right, so it's going to be minus xy times that one, and minus xy times that one. Okay. And if we want to, we can just do little sums at the side. So I'm going to move these out the way so that we can do our little sums at the side. Okay. Let's see. I don't want you to see the next question necessarily. Right. So the first question we've got to do is minus xy times x cubed. Let's see. I've got a minus times a plus because there's no sign with the x cubed. So it's a minus times a plus, which is going to be a minus. Then the x's, I've got x to the 1 times x to the 3. And we know from exponent work that we put down our base and we add the exponents. And then there's just a little y sitting alone by itself. So my first term becomes minus x to the 4y. Okay. Now I've got to do minus xy times 4y. So I'm going to go again over here. Minus xy times 4y. You can do these little sums at the side if it helps you. Okay, again. I've got a minus times, well there's no sign there, so it must be a plus. So minus times a minus is a minus. Then x, there's no other x, I'll just keep the x. Oh, I've got the 4, sorry. So minus times a plus is a minus. 4 times, oh there's no other number, so we understand actually that there's a 1 sitting in front there. So 1 times 4 is just 4. The x, there are no other x's, so I'll just put it down. And the y, well I've got y times y, which is y squared. So this answer over here is minus 4xy squared. And there we're done. Okay. And here is another question. And I'm going to let you have a minute to try and do that one for yourself. And then we'll wrap up because it's nearly the end of our time together. Okay, so I'm going to let you have a chance to try and do that yourself. Think about it, that every term in this bracket must be multiplied by the 2. Then, this minus 3. It's saying I must minus 3 times that. Then I must minus 3 times that term. And then I must minus 8 times 2b. The trickiest part is going to be this bit. Okay, give you a moment to try. Okay, first bracket, I think it's easy for us to just multiply by 2. But maybe it wasn't so easy for you. Look at what it's saying. It's just saying 2 times 4a. So, 2 times 4a. The best you can do, the only thing you can do is say, well, I'm going to multiply the numbers 8 and I just keep the a. Alright, that's the best you can do. And the same with the 2 times 5b. 2 times 5b, I'm going to multiply the numbers and keep the b. Okay, so we get 10b. Now this next bracket, you can think of it in 2 ways. I'm going to explain it one way first, and then the second way. Okay, so what we're going to do with this minus here, we could say it's minus and then just multiply the 3 in. So if I multiply the 3 with the a, I get 3a. And if I multiply the 3 with the minus 3b, 3 times 3, keep that minus and make that a 9b, because 3 times b is 9b. But notice that I've put that in a bracket. Because this minus here says I must subtract the whole result. The whole result, I must subtract all those terms. I must multiply the bracket by 3, but then I must subtract it all. So now, in my next line here, if I had kept the minus and put this in a bracket to remind me to subtract it all, this would now become minus 3a, and then minus a minus would become, so it would be minus 3a, and minus of a minus has to be plus 9b. How do you understand that? Well, if I minus a normal 3, I know which direction I'm going in. I'm just going to put this onto the page again, onto my written page. This is working with integers. Hey, if I start, let's say I start at 4, and I want to say 4 minus 3. We know exactly what we must do. We must go to the left 3 times. So that'll be 3, 2, 1. Here's my naught, but I'm going to minus 3. 1, 2, 3. Okay? Where do I land up? At 1. But what if I say 4 minus 3? What on earth does that mean? Well, you see on my number line, there's only 2 ways I can go. When I subtract a normal 3, I know that I have to go this way. So what does it mean if I must subtract a minus 3? Well, there's only one way to go. I can't go the same way as I just went before, because that would be silly. These 2 things must mean something different. And actually, there's only one way to go on a number line. You can either go left or you can go right. And so surprisingly, if we have 4 minus 3, it's actually the equivalent of 4 plus 3. Okay, because it has to be something else. 4 minus normal 3 was this. So 4 minus 3 actually ends up being this. Where are we at? 5, 6, 7. The answer is going to be 7. Okay, so let's go back to my question on the board. And I'm going to try and explain it again in one step. I'm going to rub out all that messiness and try and do it all in one step. Okay. Right. So, what we're saying is I want to multiply this bracket by 3, but I want to minus everything. So, if I multiply the a by 3, I'm going to get 3a, but it has to be minused. So I'm going to get minus 3a. Okay? Then if I multiply the minus 3b by just the 3, I would get minus 9b. But I have to subtract that minus 9b. So what you can actually say is I've got a minus, this minus, whoopsie daisy, this minus, and this minus are going to combine to give me a plus, because I'm subtracting a minus. So the minus with the minus gives me a plus, and then the 3 times the 3 is 9, and the b I'm just going to write down. And then my last term is just minus 8 times 2b, and all we can do is multiply the numbers. 8 times 2 is 16, and there's my b. And now what have we got? Oh, we've got a whole string of terms. And some of them are added and some of them are subtracted. And we know that we can only add and subtract like terms. So let's identify all the like terms. Here I've got an A term there, an A term there, no other A terms. So I've got 8A, subtract 3 of them, 8 of them, minus 3 of them, I've got 5 of them. Then I see, oh, I've got some B terms. That's 10B. Ooh, that's another B term, that's another B term. Sorry, we already underlined that as an A term. Okay. So now we want to gather up all our like terms that are B terms. So I've got 10 of them plus 9 of them. How much is that? 10 plus 9 is 19. Okay, I can think of it over here on the side. So I've got positive 19B, and I'm going to subtract 16B. How many have I got of them? 19 of them, subtract 16 of them. I must have 3 left over, and they are positive. Because they were positive 19 minus 16. And there's my answer. How does that feel? I hope it feels good. I hope it feels like, oh yes, we know this. Maybe that's how you feel. Maybe your algebra is so good that you didn't even need this lesson. And if that's the case, then that's fantastic. But I'm going to pick up next week. You can see the next topic is going to be dividing with brackets. And then we'll start combining everything. And the more we combine things, the more tricky it gets. And you might find yourself getting a little bit confused, but that's why we're doing things slowly, and that's why I'm trying to help you get some extra input on top of what your teachers are doing. So I'm sure your teachers are doing good stuff already, but it just helps to be reminded and to hear the things again. And maybe you hear them in a different way from me, and then you hear them in another way from your teacher, and then suddenly, hopefully, it all suddenly makes sense to you. And I'm hoping you're going to persevere till it does make sense. Okay. If you have access to the Platinum Maths, this is the next exercise we're going to do. Alright? So I would encourage everybody, I would like to think that we could get up to the end of 2C. Okay, so my suggestion is if you do have a Platinum Maths, that you would go up to the end of 2C, if you possibly can. Alright? And if you don't have the Platinum Maths, maybe you just take a picture now of those questions. There they are. You can see 1, 2, 3, 4, 5 questions. So if you can carefully try and do those 5 questions, and write down your answers, and then next week I'll pick up with going over those questions. Alright. And you have to, obviously, be very careful about your signs all the time. I can see the potential for a problem, well, just a tricky one over here. This one here is going to be a tricky one. Can you see? You're going to be minusing something that's positive, so that's going to be a minus. But here you're going to be minusing something that's negative. So that will probably land up being a plus. Okay. If you can give it some thought and give it your best shot, I would be very happy that you do just a little bit of homework after these sessions. Okay, so that's the area that I think might be a tricky one. And I will see you again next week. Thank you so much for watching. Thanks for listening. I know that an hour after school is quite a long time to have to spend looking at maths again. But the great thing about maths, and this is why I love maths, is that once it starts falling into place and it starts making sense, and you start getting those answers right, it can be quite exciting. Okay, so I'm really hoping that you can be making progress and you start getting answers right and it starts making you feel great about yourself. Alright, thanks everybody, all the best, enjoy Youth Day tomorrow and enjoy your week of your studies, and I expect to see you again next week on Tuesday afternoon. Thanks, bye-bye.
Thanks very much, Kari. Fantastic lesson. Thank you so much. Much appreciated.
close my presentation.